Yeah, good evening, everyone. I'm Dr. Sharmila, a cryptographer doing research in cryptography for the past 20 years and an alumni of IIT Madras. So currently I'm heading the R&D lab at Liminal Custody, and we are building infrastructure for digital asset custody. So when I joined Liminal, we were posed with a question. What if there is, so we work with the Web3 domain, not the Web2 infrastructure. So we were posed with the question, what if there is a custody that doesn't fail operationally, then cryptographically, and also in governance? So this is like, okay, you need a holy grail answer for all these questions. So this kickstarted our research activity in R&D labs. And when we spoke to most of the financial institutions and banking sectors in the Web3 domain, we could figure out that one question they always posed, that they asked us is, our key resides inside the HSM. They are secure, we know. But the pathway to access the key, how secure it is? The hard truth and the answer is your keys are hardcore secure because it's inside a hardware security module, but you are guarding with a fragile screen in front of it through some software approvals or some UI buttons. So although your key is how hard or secure it is, when your pathway or the gatekeeper is fragile, the attackers are not targeting the key, but the pathway to that key. So that's what the key essence of today's talk and the product is all about. No, it's not working. No, I'll operate it. No issues. So get into the details. I'll just give a brief introduction about what this hardware module is all about. Hardware modules are something where your cryptographic key gives birth and death and the operation inside it. It never leaves the boundary of the HSM. So it is, yeah, something that institution prefer. Even the Web2 environment uses this. But what differentiates is in the Web3 environment? In Web2, it's all about securing your encryption keys or your certificates that you want to, that you are using to protect some sensitive information. But in Web3, that's not the case. The keys are the assert itself. Okay, it's not the key that is lost. Even one compromise or a one transaction that I am able to get out of the key, it leads to a catastrophic loss which is irreversible. The entire assert is lost. We have witnessed several such incidents. So this was a question that we were trying to solve. Okay, what if hardware security modules are there, but is it good enough that just institutions should rely upon? So our journey started with explore. Yeah, the basic principle. Everybody, we are all familiar with one key, one secret, one public key, one. So I'll give you with the real-time example. What if we have some asserts in our house? How will we secure it? We'll lock it with a key. So that's the analogy in our real time. So I just wanted to go with some layman terms rather than going it cryptographically. So this is what the exact analogy for a transaction that is being signed. You have a public information which is there on chain, but the secret information which is, it's good. Everybody liked it. But what the problem is? Single point of failure. What if the key is lost? What if the key is compromised? Your entire assert it's being compromised. So institutions are not ready to rely upon this fact because this is something that will give them a irreversible loss. So this led to a journey, what if I can have multiple keys? Think of a vault or a door with multiple locks. You have multiple locks. Yeah, now you have several people. Give one key to each of the persons and you set a quorum for it. So now if it is a 2 of 3 locking system, 2 people should come at the same time, unlock it. It's more like your bank locker at the same time. What's the problem? Yeah, we have distributed the trust to two people rather than trusting one people. Is it good enough? No. The problem what it was faced by this multi-sig environment is the people who are handling this digital key, if they leave the organization, if I can do some changes within the environment, it is fine. But that requires the change in the infrastructure itself. You need to change the lock itself. That's something organizations are not preferring because you need to revamp the entire structure. So this is also not a reliable solution. So that lead to a interesting breakthrough by the community, which is called the MPC. So what this MPC, I give you a layman example. Okay, the secret recipe problem where there is a secret recipe and 4 chefs know the secret ingredients of it. They don't want to reveal how much quantity and what ingredient they are putting to the recipe. But they will come, they'll add the ingredient to the recipe. Finally, the taste score can be done, but no one will be able to identify how much of each ingredient is being added. So this is what MPC all about. There is no key. So in hardware security module, the birth and death of the key happens inside the HSM. But in this MPC, the key doesn't exist. This is something exciting for the institutions. But one thing we need to understand about the MPC protocol is, even for doing a signing transaction, whoever is participating in the signing mechanism, they need to do some cryptographic chatter. We need to talk to each other. That means the mechanism of or having isolated from the online world. So we need to come online to interact with each other. So there is no air gap guaranteed by any of the current industrial solutions that offer MPC as a wallet infrastructure. So this is where we want to step one step behind and look into the problem closer. And we had a radical question. What if so most of the institutions, what they tried is, okay, can we place one of these MPC shards into the HSM rather than putting the entire key, one part of the key. Okay, if I can put it into the MPC protocol, is that okay? That is what all the current solution providers are dealing with. But we are not okay with this solution because this completely violates the demand for air gap. Once HSM is involved in MPC, it violates air gap nature of it. So, all institutions are forced to take a choice whether they need a distributed trust or whether they want to have a hardware based trust. They can't have both. What we thought, okay, why can't we marry both of them together? Okay, have your signing key inside the HSM, but the gatekeeper, why can't be a MPC based access control? So key is inside the HSM, but there is no single access to it. We have a distributed access which is completely programmable without touching the hardware. That is, even if whoever governing your key, if they leave the organization or come into our organization, you don't have to touch the hardware module for any reconfiguration. That is completely, the HSM is completely unaware, okay, what is happening behind the hood. It can just verify some proof and it can perform the operation. So this innovation, we call it as transaction authenticity proof. So to get to know more about detail, okay, so outside the HSM, whoever is governing this key, they will provide the transaction authenticity proof, which is nothing but a non-interactive zero knowledge proof. It is not a software based approval, it is a cryptographic proof. And all these proofs are being aggregated irrespective of how many people are performing this ritual. Finally, the HSM will get to know one single proof and then it verifies the proof and opens the signing algorithm. So whatever it comes out of the HSM is just a signature and not the key. So we enjoy the benefits of a non-reachable key which is completely protected inside the hardware, and the gatekeeping mechanism is completely decentralized and completely distributed. So to get more into the details, okay, you can have the approvals from various approvers. It can be from your governance, compliance team, anywhere. So they all share a key, and after all these partial taps are being generated, it will be aggregated into a single tab, which is a non-interactive zero knowledge proof. And that tab finally has one offline component. Why an offline component? What if the entire approval flow, it's in the online environment? Again, online threat vectors are there. They know who are all the people who are responsible there. So one of the offline verification key, means authorization key, is inside the offline environment. That makes the complete approval mechanism also a completely non-reachable one. So finally, when the tab reaches the HSM, it verifies this tab, and then on verification of the tab, so here I should inform a major thing, that this verification, it's a hardware verification that happens within the hardware. If this verification is brought outside the HSM, then it is more like a software approval. So whatever the verification we are doing, it's within the hardware module. So after the hardware module verifies the tab, it performs the signing on the transaction. So this is the clear solution where we stand with respect to the industry, current industrial solutions. So we provide hardware protection for your key, and the access to the key is completely decentralized, and it completely maintains air gap, and it also eliminates the key exposure, because we have few of the keys in the online approval keys in the offline environment. And also it is a complete non-interactive. As I contradict the fact MPC always involves interaction. We use an MPC offline mechanism which is non-interactive. So this is an idea that it's a patent pending idea, and it's accepted in the National Nanyang Blockchain Conference held in Singapore. And this is the patent pending idea behind the product, which we call it air gap signing with air gap, HSM signing with air gap HSM. So now to wrap this up, before the institutions are forced to make a choice between, okay, whether you need a hardware isolation or you need a decentralized trust, we are giving a solution which enjoys the benefits of this. So here, no, security is no more a choice. It is a privilege that your solution is provable and the access is completely decentralized. Yeah, thank you.